Hello there, I am Mr. Chuku. I'm here to teach you an interesting lesson about work, energy, and power. You may have heard these words somewhere. They may mean different things to you compared to what they mean to me. But you know, in science, they have their meaning and relationships too. That's what we're here to find out and discuss. We have learned about work and power in the way science describes it. Work is measured by the force times the distance, and also represented by joules, which is the unit of measurement. Power is measured by how much work is done over time. It is measured in joule per second or watt. In this lesson, we will learn about energy in the way it is described in science. Are you ready to learn something new? Let's begin. So, what is energy? The simplest definition of energy is the ability to do work. Energy is how things change and move. It is everywhere around us and takes all sorts of forms, such as chemical energy, heat, gravitational, light, nuclear, potential, kinetic energy, and other forms of energy. It takes energy to cook food, to drive to school, and to jump in the air. In this lesson, we will learn about a form of energy that is quite important in our daily lives. It is the kinetic energy. So, what is kinetic energy? Kinetic energy is the energy an object has due to its motion. As long as an object is moving at the same velocity, it will maintain the same kinetic energy. Let me quickly say here that velocity is a measure of how fast something moves in a particular direction. In other words, a velocity is a speed with a direction. The kinetic energy of an object is calculated from the velocity and the mass of the object. As you will see from the equation I'm about to show you, the velocity is squared, and this can have a significant effect on the kinetic energy. Here is the equation for calculating kinetic energy, KE. KE equals half times m times v squared, or half mv squared for short. M equals the mass of the object and v equals the velocity. Don't worry, the equation is easy to understand. Let's find out how to measure kinetic energy. The standard unit for kinetic energy is a joule, J. Does that ring a bell? I bet it does. The joule is a standard unit of measurement for energy in general. Other units for energy include the Newton meter and M, and the kilogram meter squared over second squared, kg m2 over s2. But we will learn about these units of measurement as we go along in other lessons. In science, we say that kinetic energy is a scalar quantity. It means it only has a magnitude and not a direction. This also means that it may be large or small magnitude. Does that sound interesting at all? I think it does. Now, here's an example of how the equation works. One way to think of potential and kinetic energy is to picture a car on a roller coaster. As the car travels up the coaster, it is gaining potential energy. It has the most potential at the top of the coaster. As the car travels down the coaster, it gains speed and kinetic energy. At the same time it is gaining kinetic energy, it is losing potential energy. At the bottom of the coaster, the car has the most speed and the most kinetic energy, but also the least potential energy. For example, 1. A car and a bicycle are traveling at the same speed, which has the most kinetic energy. The car does because it has more mass. It is bigger and heavier than a bicycle. Number 2. A ball weighs around 1 kg and is traveling at 20 meters per second. What is its kinetic energy? Let's use the equation we learned earlier. Ke equals to half times m times v squared. Let's take all the pieces apart. The ball's mass is 1 kg. The ball's velocity is 20 meters per second. Ke equals to half times 1 kg times 20 meters per second squared. Ke equals to 200 J. This means that the ball has a kinetic energy of 200 joules. Number 3. A boy weighs 50 kg and is running at 3 meters per second. What is his kinetic energy? Again, taking all the pieces apart, we will have the following. Mass m as 50 kg and velocity v as 3 meters per second. Ke equals to half times m times v squared. Ke equals to half times 50 kg times 3 meters per second squared. Ke equals to 225J. Now, let's finish off with some more interesting facts about kinetic energy. If you double the mass of an object, you double the kinetic energy. If you double the speed of an object, the kinetic energy increases by 4 times. The word kinetic comes from the Greek word kinesis, which means motion. Kinetic energy can be passed from one object to another in the form of a collision or clash. The term kinetic energy was first coined by the mathematician and physicist called Lord Kelvin. That was great, right? Did you learn something new like I did? Well, I'm glad about it. But before we finish up the lesson, let's remind ourselves about some of the important things we've learned so far. A. Kinetic energy is the energy an object has due to its motion. B. As long as an object is moving at the same velocity, it will maintain the same kinetic energy. The standard unit for kinetic energy is the joules, J. Great! It is time for me to know how well you understood the lesson. Let's start with some questions. Number 1. What do you understand by the term kinetic energy? Yes, that's correct. Kinetic energy is the energy an object has due to its motion. Number 2. How is kinetic energy measured? You're absolutely correct. Kinetic energy is measured in joules. That was an interesting lesson. I look forward to the next lesson. Well, see you then.